Welcome back, everybody. This video we're going to be talking about functions and the basic components of a function, what makes a function, and how to identify one. First, let's figure out domain and range. What we have here is two relations, and two relations are simply a set of ordered pairs. So this is a mapping diagram. So we can see we have x values going to y values. That means they're paired with them. So we could list these as ordered pairs: -2, -3, -2, -1, 0, 0, 2, 0, and 4, 0. To identify the domain and range, the domain, D for domain, is simply all of the x values here, just listed one time: -2, 0, 2, and 4. That would be the domain of this relation. The range would be all the y values: -3, -1, 0. Over here, domain is all the x coordinates. So we have a -3, a -1, 0, and a 3. Those are the x coordinates of all 5 coordinates. The range is simply the y values. We have a -1, 0, 1, 2, and 3. Y values of all the points here. And then we have the identification of a function. Now, all these are relations. They're all sets of ordered pairs. But for it to be a function, it must pass what's called the vertical line test. Vertical line test, pretty easy to use. You can use a pen, pencil, and hold it across your screen. And just use it as a scanner. I'm just going to scan it across like this. And there's 4 examples here. And the rule for the vertical line test is, if as scanning it only touches the line at most one time in any given instance, then it is a function. Now notice this first one here. It's touching this vertical line a whole bunch of times. So this first one is not a function. Here, as we scan across, we're only going to we touch 2 times for the circle. So the second choice is not a function. Here on this looks like a sideways parabola. We're only touching 2 times. At most and at least 2 times, but it's more than 1. So again, the first 3 are not functions. Let's see if the last one is. 1 time, 1 time, 1 time, 1 time, 1 time. As we scan it across, this right here is an example of a function. Definition of a function: for every input there's exactly 1 and only 1 output. And we can see that graphically with what we call the vertical line test. And we'll do it again here. Let's get another vertical line. And we will scan it across. Even though there are just dots, coordinate points here. Alright, right here, see how we're touching twice? First example is not a function. Scan the second one. Once, twice. There are 2 dots touching, 2 points touching. This one is not a function. Right away here on the third one, we see 2 points touching at once on the vertical line. It's not a function. They touch again here. Look at the last one. 1 time, 1 time, 1 time. Once. The last one, another example of a function. Passes the vertical line test. For every input there's exactly 1 output. And then we're going to figure out which function is represented from the table here. Here's the x values. Here's the function values, also known as the y values. We can think of these as y values. Now, notice as the x values decrease, the y values increase. And we can look at that the other ways. If we start from the bottom and go up, as the x values increase, notice as we go up, the y values decrease. So there's a sort of an inverse relationship. The slope of this line, if we were to graph it, would be negative, showing that inverse relationship. So our possibilities here are A and D. Now, let's pick a couple values and see if we can figure out which function matches. Let's pick D. Let's test D first. And let's choose this coordinate point here. So according to this, the function value has 2 if we were to plug in 5. So here's -5/3 times 5 plus 5. Alright, this gives us -25 over 3 and negative 25 over 3. I believe that's negative 8 1/3. Negative 8 1/3 added to 5 does not give us 2. So D is not going to work. Let's see if A will. 2 is the function's value when the x value is a 5. So 5's cancel, we're left with negative 3 plus 5. Negative 3 plus 5 is in fact 2. So A does work. This function right here, negative 3/5 x plus 5, does model this. If we were to graph this like on Desmos or something, we would find all of these coordinate points that correspond. All right, let's look at another here. What's the function rule? Okay, we have to use what we know about functions. Let's go with slope-intercept form. The number next to x is the slope, and the number by itself is the b number, or the y-intercept. As you can see here, this is crossing at 2. And so that would lead to this function right here, b. The only one is positive 2. Well, actually, nope, it's a negative 2, isn't it? I'm wrong. We have values that could be a, could be c, could be d. Notice the slope is negative. It's going down from left to right, so that's going to eliminate d. That is a positive slope. And let's find another point here on the line right there. Notice we are going down 2 for negative 2, and we go to the right 3, plus 3. Look for a slope of negative 2/3. And it looks like C is our winner. All right, and finding a value of a function. What is f of negative 3 when f of x equals 2x minus 2? So that means we're going to substitute in negative 3 for x. 2 times negative 3 minus 2. 2 times negative 3 is negative 6, and negative 6 minus 2 is negative 8. So the value of the function is negative 8 when x is negative 3. Next, we're just going to graph a function using Desmos. G of x equals negative 0.5x plus 3. Let's head on over to Desmos and see how that works. G of x equals negative 0.5x plus 3. And notice how the graph looks. We'll zoom in to see exact values here. So it is crossing at 3 on the y-axis. Notice the slope goes to go from one point to the next. We go down 1 and right to negative 1/2. This is how the graph looks using Desmos. Let's look at another one here. This time let's make it negative 2/3 x minus 3. Negative 2/3 x minus 3. Just change this to a 2 divided by 3. Change this to a minus 3. And here's how it looks. Let's zoom in a couple times. Notice it's crossing at negative 3 on the y-axis. And we go down 2, right 3, slope negative 2/3. That's how we get to the next point on the graph. But here's how it looks graphed using Desmos. And the last one here, Greg read 25 pages of the book each day until he finished the book. His book was 400 pages long. Which sketch represents the situation? Well, the y-axis is all the pages remaining, and the x-axis is the number of days. We start out with 400, so it's either going to be this last one or this first one. And if he reads 25 pages a day, the number of pages remaining decreases. If we take 400 divided by 25, we will get 16. That's how many days it takes. Down here on the x-axis, we see that at 16 days. So this one right here, let's make sure we highlight it, is the best representation of the situation for Greg, starting with 400 pages and the number of pages remaining goes down by 25 until 16 days pass and there are 0 days remaining. All right, well, thanks for watching. Hope this helps your understanding of functions.